This problem asks us to find the equation of the tangent line to a parametric equation that's defined as x being t cubed plus 1, y is equal to t to the 10th plus t, and t is equal to negative 1. We'll begin by making a note that dy dt is equal to 10 times t to the 9th plus 1, and dx dt is 3 times t squared. It's true that dy dx can be rewritten as a fraction, where the numerator is equal to dy dt, and the denominator is dx dt. Since we just found out what each of those expressions is, we can write it in as 10t to the 9th plus 1 over 3 times t squared. We want to know what this value is when t is equal to negative 1. So we'll insert negative 1 in for t in this numerator and denominator. 10 times negative 1 to the 9th would just be negative 1. So we get negative 10 plus 1 divided by 3 times negative 1 squared is just 1. That fraction simplifies to negative 3. We also need to know what the point is in terms of x and y when t is equal to negative 1. We can do this by replacing t with negative 1 in both of the initial two formulas. X is equal to negative 1 cubed plus 1, which is 0. And when we replace t with negative 1 for y, we get negative 1 to the 10th plus negative 1, which again is equal to 0. When we're trying to find the equation of a tangent line, or any straight line, the general formula is y equals mx plus b, where m is equal to the slope. Since we know that x and y are equal to 0 when t is negative 1, and that the slope m is negative 3, then it's quick to solve that b is equal to 0. And therefore, the equation of the tangent line when t is equal to negative 1 is simply y equals negative 3x.